Okay, we're going to walk through the changes that we made to the studio's Ampeg B15nf from 1964. We wanted to convert it from its original state to the B15nc circuit, which is cathode biased and has a few other changes that I can walk you through. But this is the schematic for the NF, which belongs in this amp. Love how they put the schematic right on the lid. And as you can see, it's fixed bias. So we have removed the feed to the bias supply right at the rectifier pin. So pin 4 of that rectifier used to join to that trace to take the signal up to the bias network to do the negative fixed bias for the 6L6 power tubes. But we have severed that and essentially de-energized all these components of the bias network. I've lifted the 47K, the bias can, the bias filter cap, and the diode of the bias circuit to free up this eyelet they were attached to. These are fine because they are just inert because they're not energized anymore. I'll tie them off nicely, but they'll be okay to just dangle. And in place of the bias, the fixed bias network, we have to add a cathode bias network. So we added our 250 ohm cathode resistor and 47 microfarad 100 volt bypass cap. I'm using two 10 watt resistors to make the 250 ohm because I've got a 330 and a 1K, which gets us right there. 250 is an impossible value to find in these 10 watts, so we made our own. That is fed by the cathodes of the 6L6s. So I've lifted those from their pin contacts to ground, because they used to be grounded in the fixed bias network. And I've taken the cathode of one power tube directly to the cathode of the other power tube, and then tie them to the new cathode bias network. This board had an empty eyelet on each side right here, one going to ground, one floating, so it's just the perfect spot to drop this in. These go to ground on this end, of course. This is fed by the cathodes of the power tubes. So that leaves the 270K grid leaks that used to be attached to the fixed bias network, now floating. So we've taken them with this jumper to ground. Convenient ground right here. So yeah, you can see one of them there, the other's over here. They have a trace. So that was the junction of the 270K grid leaks and the old bias network, and now it's the junction of the 270K grid leaks to ground. So that takes care of the power section. You can see that this first filter node has been replaced. That's not part of this operation, but that was done before. So the next difference is in the phase inverter. Instead of the 120K plate loads here on the NF circuit, the NC circuit has 47K plate loads and runs at a much higher bias operating voltage here. So instead of seeing 230 volts on these plates, we're gonna be looking for more like 300 volts once we've put the 47Ks in. And just in case we wanted it to be reversible, instead of swapping out the existing 120Ks, we've paralleled on 100Ks to those here and here. You can see the 120K hiding under it, to give us 49K. So that's pretty darn close, and it's gonna be perfect. So So that takes care of the phase inverter. Actually, I guess before that, we've on the NF here, there's no screen resistor. So on the NC, there's a 1.5K screen resistor. So here we've added our 1.2K 10-watt screen resistor. It's getting a little crowded there, but these will be fine. It's not that tight of spacing for the amount of heat that's going to come off it. So there's the screen feed going through here to this trace, and this trace goes to both power tubes and screens. So we're inserting the 1.5K in the B+ line on its way to the screens. Then over in the preamp section, the only difference component-wise is instead of 470K and 220K on the plates, the NC cathode bias version one that we're converting to is 470 on both. So that's been done here with a single 470. I've left the 220 there decommissioned just in case we want to revert. And then the big difference in the tone circuit volume is the order in which they happen. So on this model, the NF, it goes input jack to the grid, to the volume pot, to the next grid, to the tone stack, to the phase inverter. And on the NC, it goes from the input jack to the grid, to the tone stack and all its components and cathode resistor and everything, then back to V1B in its case, and then to the volume pot, and then on to the phase inverter. So just the order of this triode and its volume pot and components and cathode resistor and everything comes after the tone stack and its triode and its plate load and its cathode and everything. So really we're just reversing those. So what we've done is swap the two grid inputs. So now we're feeding jack directly to V1A, which is pin 1, and then the plate of that, as it did before on this trace, goes up to the tone stack, and then the tone stack output now feeds V1B's grid, which in turn feeds the volume pot, which is then taken to the mix resistors and off to the phase inverter. So that's what's been done. The remaining differences would be, instead of a 1 meg load resistor on the input jack, it's 100K on this schematic. It actually looks like 1 meg on this actual unit though, so maybe that's misprint on the schematic, or someone's already decided they like the 1 meg version, which is more standard, Fender does and everything. So we'll investigate that and maybe change it, but the majority of the conversion is now complete. So we'll fire it up, take some measurements, make sure it's all cool. Okay, we've got the B15 after its conversion. I'll fire it up, connected to its dummy load, and everything is looking great. So power tubes are cathode biased now. They're biased up about 61 milliamp, 25 watts. So that's, 83 or something % max plate dissipation. Pretty good for cathode bias. And then as we look at other voltages around and compare it to the NC schematic, everything is bang on. So we've got raw B plus 440, exactly like the schematic. And we've got screen, our new screen post resistor is here. 421. Schematic says 425. Pretty darn good. And then our plates on the 6L6s, 430, exactly like the schematic says. And then plate minus cathode, of course, is for 398 here, as you can see, which means that our cathode must be around 30, 32, yeah, 31. So that's all bang on as per the NC schematic. Then we move over to the phase inverter, which instead of being operating at 220 volts on the plates should be closer to 300, and that is pin 2. Yeah, 282. So that is great. And then we go over to the first preamp tube, which instead of operating at 160 as per the NF, the plate should be closer to 120 on the NC schematic. So that'll be pin 2. And oh, I slipped off the pin there. Yeah, 115. So we are looking perfect. I think we should plug it in and make sure the tone stack works the way we think and that it sounds awesome. But all the voltages look correct and are exactly like they're supposed to be on the NC schematic.